On to number 20. Number 20 gives us something in factored form and wants us in standard form. Well, standard form is ax squared plus bx plus c. So this is a really fancy way of saying, hey, multiply and combine everything back together. Whoever had this trinomial, they factored it out. Now I want it back together, okay? To do that, I just have to multiply. We've got x plus 2, x minus 3, and then we had this ticky-tacky plus 5 stuck out on the end. Well, if we're going to put it all back together, we've got to do our multiplications. X squared minus 3x, positive 2x minus 6. And notice that plus 5 is still hanging out back, but we've gotten rid of all the parentheses now, so we can combine some like terms. Those are like terms, and those are like terms. X squared did not change, but now we have minus x minus 1 when we combine all our like terms. For anyone that had me in class today or when was here, remember I described to you that you could cheat on this problem, and you can cheat on a lot of these to check them. 20 you can check by typing in the original equation and option C and making sure they're the same exact graph. 21, please don't miss it, guys. If you take a look at the graph of this, you can either graph your original, or I would suggest you, by the way, graph the original. If it's going to keep asking you about x plus 2 and x minus 3 and plus 5, I would just graph this. I wouldn't risk the fact that maybe you made a mistake on number 20 if you didn't check it, and you started just using your answer for number 20 for the rest of the time. I wouldn't do that. I would use the original for my actual graphing, because I know the original is right because I haven't messed with it yet. So it wants to know, what is the domain? Domain just means what are the possible x values, or how far left and how far right can it go. Well, as with all parabolas we've seen, they're going to go as far left and as far right as they possibly can, which is negative infinity to positive infinity, or all real numbers. Okay? Notice this is spelled out. We're also used to seeing the symbol. Number 22, though, is a little bit trickier. It says identify the range. Well, to identify the range, that's rangy, meaning how or what are our possible y values. That means up and down. And you notice with this parabola, it's going to go up forever because it's going to have little arrows up here at the top. But it doesn't go down forever. It has a minimum. It has a distinct point where it stops. Okay? So it has a lowest point. We have to find out what that y value is. So we second calculate. Number 3 is a minimum. And it's going to ask for a left bound. So we go to the left of this minimum. Here's our minimum. We are to the left of it. Press enter. Then we want to go to the right of it. Here's our minimum. We are to the right of it. So you press enter, enter. So that minimum's y value, the lowest y value we ever get, is negative 1.25. And now we just have to decide, is our entire graph greater than that minimum or less than that? And just think about the definition of a minimum. Here's the lowest point ever. Well, the rest of the parabola is way above that. If the rest of this parabola was below that point, that would make that a maximum because it'd be the highest. But it's the lowest point, meaning the rest of my y's are greater than or equal to negative 1.25. It's just like an asymptote. It's never going to get lower than that number. Identify the y-intercept. Please be careful, guys. This is not asking for zeros. The y-intercept is where does it cross the y-axis. And the easiest way to find that is in the table. Remember, our x value for a y-intercept is always 0 because it's got to be on this axis, meaning the x's is 0. And so in our table, it tells us that point is 0, negative 1. 0, negative 1.